My team and I decided to focus on data provided to us through the Chicago Police Data Project, which is actually a data initiative by the Invisible Institute. The Invisible Institute is a Chicago-based nonprofit that aims to use data-driven initiatives to hold public offices accountable. And so in this specific project, this Chicago Police Data Project, we were looking at data that was pertaining to brutality counts, so instances of citizens being brutalized by officers, Chicago police officers, and then this data being paid out in forms of settlement or handled internally by the police department of Chicago. So part of the raw data that we were actually provided from this project pertained a lot to the actual police officers themselves. So we have data area, data officer, officer history, etc. And so these are all tables available in the data set. And later on, as we explore further, we found that there was, also this was combined with a lot of the instances of the tactical response report, TRR, which were the actual reports filed against these officers that specify where these instances of brutality occurred and the conditions for these instances of brutality. So we actually had a chance to explore this data set as we were given it in a different class, our data science class, and we thought that some of the machine learning applications of this type of data could actually be very, very powerful, and we wanted to apply some of the tools and mechanisms that we learned through our through our machine learning class this quarter to this actually data that we had some time to play around with in a different setting.
The question I worked on was to predict the brutality level or the case of police brutality given details of a case and the officer there, and in which beat he's in. We combined two databases here to do this prediction, and in doing so, we found that a lot of the data we had wasn't encoded well, encoded as in it wasn't numerical. So I'd run a label encoder using sklearn library to be able to encode all values of the data given. From that, we given encoding of all values, we tried to predict the action level, as any action level greater than 4 was a case of police brutality and less than equal to 4 was not. So we were not doing the brutality label as that data was kind of inferred from it. So as long as we can predict something that's given, we were able to do something that's inferred. And action level and action category are the same in terms of wording. We used a decision tree classifier initially and we got an accuracy of 91%, but this accuracy was flawed as we'd use examples of resistance type, action, and resistance level. We removed resistance type as well as action, as there were obvious classifiers as to how severe the action would be, and making our model a little more efficient in prediction. We found that since these features are actually very important, the decision tree classifier's classification dropped severely to a 68.29%. And we found that the feature importance of all the classes so far, and the most important features was resistance level, which was important for our classification, and we got good information about it. Further, we used a random forest classifier, in which we used about 100 decision trees, and majority vote of this decision trees was used to classify a particular example, and we got a good 80% accuracy, which worked well, and a very similar feature importance level. To further work on it, we used a multi-layer perceptron model and saw that it failed severely. And we believe that a random forest classifier would work best with this data to predict action level, which would help us infer the brutality level of the brutality category of a certain case.
We attempt to build two predictive models, one targeting the hardship index and another one targeting the police brutality rates of the 77 Chicago community areas. We will be using our socioeconomic data for training. Based on the fact that we know there is a close relationship between the hardship index and socioeconomic data, we hope that by using a linear regression model with the right tuned weights, we can predict the hardship index based on the attributes that define socioeconomic data. On the other hand, we do not know of any relationship that should exist between the socioeconomic factors of a community and the police brutality rate. Therefore, we expect that even with well-tuned weights, the linear regression model for predicting police brutality rates should perform poorly. As you can see here, we do some data pre-processing, some data splitting, and make a few plots to see the correlation between our target values and our data. As it can be seen, there appears to be some linear relationship between the hardship index and the socioeconomic factors, as opposed to the brutality rates and the others. After training our model and scoring it, we see, just as we expected, that there is a good score for the model that predicts the hardship index and a very poor score for the model that predicts brutality rates. Therefore, we understand that because the brutality rates are not closely related to socioeconomic factors, even with the well-tuned weights, the model performs badly. On the other hand, with like excellent weights that are tuned here, we can see that our model is very well able to predict the hardship index given socioeconomic factors.
Problem, we chose to classify whether a beat area was brutal or not. We did this using the scikit-learn library and specifically the k-nearest neighbors classification method. The cool thing about this specific problem was that we got the opportunity to actually do classification rather than a linear regression predictor. As you can see here, we called in the k-nearest neighbors classification object, and then using cross-validation, we decided how to break down the data set to really use it as a learning data set and a testing data set. We also decided to test using folds, specifically 10 folds. And as you can see here, using the folding method and 10 iterations or 10 folds, it converged to 100% accuracy. And using our cross-validation method, we got 97.6% accuracy. So pretty impressive accuracy. However, next steps, I would say, for a project like this would definitely be to incorporate more source data, specifically features such as our brutality count and crime count, and see how the labels or how the classification holds up on that new data. But overall, the actual classification was quite accurate, and this was a pretty good model to run on.